now let's see a little more about the ions. And before going to that, we shall see the periodic table. You can see the periodic table again. So, do you think all the elements it is going to form ions? No. There are, there are some elements, only some limited number of elements it is going to form ions. So you can see that in the first two row of periodic table, that is nothing but the alkali metals and alkaline earth metals. So here it is. So lithium, sodium, potassium and rubidium and cesium. So here it is beryllium, magnesium, calcium, strontium, barium. So these two elements, because it got only one electron, so it will lose only one electron, and this second group it will lose two electrons. So, and hydrogen H plus, and similarly then aluminium also it is got a tendency to lose three electrons. Now if you go to the right of the periodic table, so you can see in this last, so the halogens, so 17th group. So in 18th group there are 18th group or 0th group there are inert gases that doesn't lose electron, that doesn't gain electron. So fluorine, chlorine, bromine, iodine and astatine. So these elements, it got a tendency to accept one electron. Okay, and now 16th group. In the 16th group, there is oxygen. So oxygen got a tendency to accept two electron. Okay, and sometimes sulfur also. Sulfur also it got a tendency to accept two electrons. Okay, and now you may tend to ask, why those elements in the 14th group or like like a 14th group or like a 15th group, why it is not forming ions? The reason is very simple. See, carbon, for instance, you can say carbon, its atomic number is 2, 4. So it can, in order to gain octet, either it has to gain 4 electron, or in order to have a completely filled shell, it has to lose 4 electron. So let's see why it is not forming. See, for instance, it got 2 shells, right? 2 shells. So 1, 2, 3, 4. So this is actually 6 positive charges are there and 6 negative charges, right? When it is losing one electron, it will become 6 positive charges and 5 negative charges. This is still a feasible task. Now it will again want to lose electrons, so then it is going to be 6 positive. So here it is 1 negative charge, C minus, carbon minus. So again 6 positive charges, 4 negative charges. So this is going to be 2 negative charge. Okay. So what you need to know is, what you need to know here, all the 6 positive charges in the proton, it attracts these electrons very fairly. If it loses one more electron, 6 positive charges, okay, it is going to attract, how many? 3 electrons. So the attraction, it will be very fierce. When more positive charges are there, it will attract all the electrons very fiercely. Okay, and it is very difficult to release the electrons. Very difficult to release the electron, and very difficult to overcome this force of attraction. Okay, this is what you need to know. This is what you have to understand. So all ions will not form ions. Sorry, all atoms will not form ions, because it requires more energy to remove the electrons. Sometimes it requires more energy to add the electrons also. Okay, and now you can say this the elements which is going to form positively charged ions are something which is on the left of the periodic table, and the elements which is going to form negatively charged ions are on the right of the periodic table. So in the rightmost and the leftmost. So mostly these elements are going to form ionic compounds. Okay, now you can say like this 0th group elements. 0th group elements. See, helium. I shall write here. So helium, neon, argon, xenon and krypton. Sorry, krypton and xenon. Okay. So these elements are completely filled. So it's 10. So it's 2, 8. So here it is 2, 8, 8. So same way, it is very difficult to add the electrons. Very difficult to add the electrons. here also, it is very difficult to add the electrons to this, right? And it cannot gain, it cannot lose electrons, right? Because it got a very high tendency to, it doesn't take up electron, it doesn't lose electrons, so it doesn't form ions. Any species which got a tendency to throw electrons or gain electrons, that is the one going to form ion. That is not the case with the zeroth group elements. Okay. Let's see the name and the formula of some compounds. For example, we can see, for instance, the name of ions in a compound. Suppose I gave you this compound, okay, sodium. So the naming should be, you see the positive ion, how to name the compound, and negative ion, it is fluorine, right? So the ions we should end with the IDE. So this is sodium fluoride. And vice versa, suppose if I ask you to give the formula of compound, if I tell you the, just the name, then let it be, I can say sodium sulfate. See, sodium it is Na plus 2 minus. Okay. Here one thing, Na is having Na positive charge. Here, in order to balance this one positive charge, two negative charge, here it should have two positive charges. So you can just multiply 2 into Na plus. So this is S2 minus. So this is going to be Na2S. Okay. So Na2S, and if I tell you another name, so let it be zinc phosphate. Not that. Let it be like potassium chloride. So let it be potassium chloride. I am asking you to write the formula of so you can say it is K plus and Cl minus. So both are having same charges, no need to balance. You can just combine and you can write KCl. So this is potassium fluoride. Wow, nice, right? See, sometimes in this periodic table, see, not all elements are, not all people are same. So same way, not all elements are also not same. For instance, you see sodium, so it is going to form Na plus ion. Okay, calcium, Ca2 plus ions. Okay, calcium will not form Ca3 plus or Ca plus ions. This is not going to happen. And sodium will not form Na2 plus or Na minus ions. This is also not going to happen. But not that, this is not always the case. Sometimes for some elements, say for example, transition elements. See, transition elements you can see in the periodic table now. You saw, right? So the transition elements are, it is in the middle of the periodic table. See, this transition elements, it forms multiple number of ions. For instance, see, silver. Of course, silver form only Ag plus ions. Zinc, it form Zn2 plus ions. But there are some other elements. For instance, like iron, Fe. Iron, it also forms Fe3 plus or Fe2 plus. Okay, Fe3 plus or Fe2 plus, so both the type of ions it will be showing. Okay, so this is the case. And now, and also, this copper, Cu2 plus or Cu plus ions. So this is both the type of ions it will be showing. And Cu2 plus or Cu plus ions, so both the ions, it forms both ions. Now what you can know is, see, if you see it's a compounds. For example, you see the formula, let it be copper 1 oxide. So you can say copper 1. Do you know what this 1 it is suggesting? It is the number of what is the charge in that. So you can say this is going to be CuO. Okay, this is going to be CuO, and because here the copper is having +1 charge. Sometimes like there is copper also have a copper 2 oxide. So this is having Cu2O. Sorry, here it is Cu2O, here it is CuO. Okay, because here copper is having +2 oxidation state. And also for if you are checking the iron, FeCl3. So here this is a iron chloride, iron within bracket 3. Okay, and if it is FeCl2, so this is iron iron 2 chloride. Okay, so here because here in the first case it is iron is having +3 oxidation state. Second case iron is having +2 oxidation state. This is what it is, and for many compounds this is not the ions, I mean like it's positive ions, I mean positive atoms are going to have many type of ions, I mean like many charges it is going to have. Okay, and for example let it be, and some transition elements it will be having only one charge. For instance zinc, it is ZnCl2. Here what you need to know is zinc, it is going to have a +2 charge. Okay, in order to balance that, it will be binding with the Cl- and Cl-, something which is having say only one negative charge. Okay, so this is a reality with the zinc chloride. Okay, and for FeCl3, you can say like Fe is having 3 positive charges, so it is Cl-, Cl-, and Cl-. Okay, so in order to balance these 3 positive charges, it is going to bind to the 3 negative charges in chlorine. Wow, yeah. At least some of you might have seen in chemical formulas. See, there will be calcium carbonate, so or like magnesium sulfate. So this is a positive ion, 2+. This is 2-, 2-. Okay, so there are positive as well as negative ions. What you need to know is, so these are cations. Positively charged ions, we call it as cations. These are anions. Okay, so the anions, it is not like a Cl- or F- or S2-. These are just contain only one atom, right? So there is only one atom, but it contains not 2 atoms, so sulfur and oxygen. Oxygen it is in 4 number here. Here it is in 3 numbers. So these are also in fact ions. It contains more than one number of atoms. So what you have to know is, see these type of ions we call it as compound ions. Compound ions. Okay, compound ions it contain more than one atoms, and it is in some fixed ratio. There are many compound ions are there, not this alone. Say for instance ammonium ion, so it is NHH. So this is ammonia ion, and OH- hydroxide ion. Okay, and then NO3-, nitrite ion, and then actually sulfate. But this is a sulfate ion. Okay, SO4 2-. Okay, I can say S double bond O, then O, SO4, right? Minus. So this is sulfate ion. So there is only 2 charges, because one sulfur it is bonded to 4 oxygen, and again carbonate ion. So O-, okay, this is carbonated because this is having 2- charges. Okay, and carbonate ion, and so on. Like there are many ions are there. One carbon it is bonded to 1, 2, 3, and 4. 4 oxygen plus 1 carbon. Here it is 1 sulfur plus 4 oxygen. Okay, and then also bicarbonate ions. Bicarbonate ions are HCO3 minus. This is bicarbonate ion. Okay, so there are these are like these are ions, or like these are the ions which is bonded to more than one number of atoms. So these are in fact like compound ions. We can call it as a compound ions. And now